Если вы будете укать против нас и будете опять готовить нападение, мы так ухнем, что больше не будешь укать.
The first secretary of the Communist Party of the Soviet Union, Nikita Khrushchev, was partial to missile technology, which ultimately influenced the formation of the USSR's defense strategy. During his rule, programs to create ballistic missiles and spacecraft were actively developed. Khrushchev considered missiles an important tool for strengthening military power and demonstrating technological superiority. But this approach had a negative impact on the development of the country's military aviation, and many promising projects were rejected. However, the rapid development of the US Rapid Reaction Forces in the early 1960s, especially carrier strike groups, forced Khrushchev to change his point of view and agree to the development of a new strategic reconnaissance bomber. After a thorough analysis of the tasks that the new aviation complex was to perform, the State Committee formulated the main requirements. First of all, special importance was attached to the possibility of striking large tonnage surface ships such as aircraft carriers and other naval and merchant vessels, as well as ground strategic targets, silos with intercontinental ballistic missiles and command posts. Strategic reconnaissance was considered a secondary role. The bomber was to have a maximum speed of 3 Mach, a cruising speed of 2.8 Mach and a range of 3,720 miles, and also carry 2 air-to-surface missiles with a launch range of 310 miles. The airframe design was to be made of advanced materials that would meet the strength and temperature characteristics for flights at high speeds and altitudes. The ability to take off from both paved surfaces and dirt strips was envisaged. The Sukhoi Aircraft Design Bureau immediately proposed the T-4 project, also known as Product 100. The second designation corresponded to the weight indicated in the tactical and technical characteristics, 100 tons, so it was given the nickname Sotka, but in reality the weight of the T-4 exceeded 130 tons. The alternative name later served as a code after the aircraft received the status of top secret. Work at the Sukhoi Design Bureau began in September 1961, with design work headed by Deputy General Designer Naum Semenovich Chernyakov. About 3 dozen aerodynamic and design layouts were worked out, and the final design of the aircraft was somewhat different from that presented in the draft design. The T-4 was designed using a tailless design, a characteristic feature of which is that altitude control is achieved by planes installed on the trailing edge of the wing, i.e. elevons. The wing itself is triangular in shape with a thin profile and a break along the leading edge. Destabilizers or front horizontal tail surfaces are installed closer to the nose, which are designed to provide or improve the longitudinal controllability of the aircraft. The fuselage consisted of several parts: a deflecting nose section, which changed its position depending on the flight speed, a 2-seat crew cabin, behind which there was a separate compartment for onboard radio-electronic equipment, a fuel compartment, and a tail section where the brake parachute was located. The rudder was divided into 2 parts, which increased controllability. The T-4 prototype was equipped with a periscope, which was used for viewing with the nose section raised. Several options were considered as a power plant: the R-15BF-300 from the Tumansky Design Bureau with an afterburner thrust of 33,000 pounds force. This engine was specially developed to improve the performance of the MiG-25 Foxbat interceptor. And the second was the Kolosov RD-3641 turbojet engine with a thrust of 35,270 pounds force, which eventually became the heart of the Sotka. At the same time, the design bureau of Alexander Berezniak was tasked with developing an anti-ship missile for the T-4. At that time, Andrei Tupolev was already recognized as the leading Soviet designer of large bombers and, having by chance gotten rid of competition from the Myasishchev Design Bureau, was far from delighted with the emergence of a new rival in the person of Sukhoi. Tupolev knew Pavel Sukhoi well, since the latter had been his assistant for many years. Irritated by the fact that the young upstart was challenging his authority, Tupolev declared at a meeting of the State Committee for Aviation Technology, "Sukhoi will not cope with such an airplane. I say this because he is my student." But Sukhoi quickly parried the criticism. "It is precisely because I am your student that I can handle it," he replied. In the spring of 1962, a competition was organized. In addition to the Sukhoi Design Bureau, the Tupolev Design Bureau took part in it, proposing the Tu-135 project, and the Yakovlev Design Bureau with its Yak-33. All three options were submitted to the evaluation committee for consideration, but the Yakovlev project was quickly rejected as it was too small and did not meet the requirements. However, the duel between Tupolev and Sukhoi continued for a long time, with a significant part of the disputes concerning the choice of construction materials, duralumin or titanium and steel, but in the end the titanium T-4 Sukhoi won. The next task was to find the optimal aerodynamic configuration that would allow for long flights at high altitudes at a speed 3 times greater than the speed of sound. Pavel Sukhoi took the T-4 project very seriously, but many of his colleagues did not share his enthusiasm. Evgeny Ivanov, Sukhoi's first deputy, was not a fan of the design bureau working on large bomber projects and was against the T-4 from the start. Some heads of other departments within the design bureau also disapproved of this deviation from the traditional fighter development field. Despite this, the T-4 project and its development continued, and concepts for reconnaissance, long-range interception, and passenger transport aircraft were even presented. In 1966, preparations for the construction of the aircraft began. New technologies were used in the manufacture of the aircraft, many of which had no analogues in the Soviet and world aircraft industry. At this stage, doubts still arose about the technical innovations incorporated into the design, especially the fly-by-wire control system, which was the first in the world to be created for a production aircraft. By the way, by that time, even the USA had not yet managed to use the fly-by-wire control system on its aircraft, and did so several years later on the F-16 fighter. Lively discussions arose about what should be used: a traditional control wheel, familiar to heavy bombers, or a control stick, typical for fighters. In the end, the second option was chosen, since the classic control wheel of heavy aircraft took up a lot of space and blocked the view of the small cockpit. The latest technologies were used in the T-4 production process, which made it possible to automate up to 95% of welding work. The material utilization rate increased significantly compared to the assemblies of previous aircraft designs, which minimize production waste. According to estimates from the National Institute of Aviation Technology, a complete transition from monolithic parts to prefabricated welded structures in serial production should have led to a 70% reduction in material costs, a 45% reduction in labor intensity of the process, and a reduction in production cycles by 2 to 3 times. On August 22, 1972, test pilot Vladimir Ilyushin and navigator Evgeny Alferov took their places in the cockpit of the flight prototype designated Production Model 101. After starting the engines, the aircraft moved to the takeoff position, and the observers were filled with awe. A short takeoff run, and the titanium bird soared into the sky. Wide triangular wings, a narrow as an arrow 147-foot fuselage, and a predatory forward-tilted beak of the cockpit created an impressive appearance. The first flight was a success. The aircraft was easy to pilot, easy to control, and had good stability. Despite its impressive dimensions, this new experimental aircraft was distinguished by ideal aerodynamic shapes. By October 1974, 10 test flights had been performed, simultaneously correcting minor design problems in the use of titanium materials. From 1966 to 1974, 4 airframes were built, 1 for static testing, Product 100S, and 3 for flight testing, Products 101, 102, and 103. There were plans to assemble 3 more copies. For this, they even began to create units, but after 1974, flight tests ceased. And at the end of 1975, by an official government decree, work on the T-4 was completely closed. The true reason for freezing the Sotka project is still unknown, but there are several assumptions. Despite a number of successful flight tests, it was never possible to create a unique avionics and weapons for the aircraft missile complex. It took more time and money, and those people who make the final decisions clearly did not like this. The second reason was that by that time, serial production of a cheaper analog of the T-4, the supersonic missile carrier Tu-22M Backfire, had been mastered. And the third reason was foreign policy. In the mid-1970s, the US and the Soviet Union were negotiating the limitation of strategic weapons, and the USSR was primarily interested in this, since the leadership understood that the country was not capable of continuing the arms race. So the adoption of a new strategic bomber was clearly beyond the scope of the agreements. The T-4 Sotka was a representative of a new generation of bombers, or as test pilot Vladimir Sergeyevich Ilyushin put it, an airplane of the 21st century. But by chance or thanks to ill-considered decisions of the military political leadership, in 1975 the first flying prototype was sent to the Monino Air Force Museum for eternal parking, and the remaining airplanes were cut up for metal and melted down.